Hello, ladies and gentlemen. Welcome to Math 30-2, Chapter 4, Section 3, Multiplying and Dividing Rational Expressions. Now, today, we're going to compare the strategies for performing a given operation on a rational expression to strategies for performing the same operation on rational numbers. We're going to determine the non-permissible values when performing operations on rational expressions. And we're going to determine in simplified form the product or quotient of two rational expressions. Product and multiply, quotient we divide. So here, now there's not a lot to this lesson, so pay attention. Here, state the restrictions and simplify. Now, in an earlier lesson, we talked about the denominator, the restriction here. Denominator cannot equal 0. Okay? So, that means we have to solve for a. So in this case, the process is 12. A to the fifth cannot equal 0. And the fifth root of both sides. The fifth root of a is a. Fifth root is 0, 0. So our restriction, our non-permissible value is a cannot equal 0. Right? Now, the simplify part. When I do this, I can split it up into numbers and the variables. So, what is minus 18 divided by 12? Well, I don't know offhand, but I do know I can divide both numbers by 6. That becomes minus 3, 2, 4, minus 3 halves. Now, a squared divided by a to the fifth, that's cancel 2 of these, so I'm down to 1 over a cubed. And I would write that out as minus 3 over 2 a cubed. And my restriction, and that brings the value of a cannot equal 0. So far, so good. Okay. Then the next part, now the exact same thing. The denominator down here. Now, I want you to note 3y minus 15y squared. This goes back to factoring. We did this a few lessons back. So 3y minus 15y squared does not equal 0. This one's a little nastier because of the minus, which means we have to factor out something from each term first. Okay? So 3 and 15, you have to be thinking this early. Like also divided by 3. And note, I have a y and a y squared, so I can factor the 3y from both of them. So that's a 3y. And what's left? 3y divided by 3y is 1 minus 5y cannot equal 0. Right? Now here, this is important. I have two terms multiply together. That's why I factor first. Now 3y cannot equal 0. So 3y can't equal 0. Now the other possibility, since I'm multiplying two numbers together that can't equal 0, then 1 minus 5y can't equal 0. Check 1 over both sides. Minus 5y can't equal minus 1. That looks like it's 5 to get the y all by itself. And y cannot equal 1/5. Okay, because if I put in 1/5, then all of a sudden it equals 0, and we can't divide by 0. Now, the other part is simplifying this mess. Now, I just factored the denominator, 3y, 1 minus 5y, right here. So, I save myself some more. Then I go 6y on top. Since I'm multiplying, now I can cancel stuff out. 3 and 6 is 1 and 2. Then I cancel 1y down to y cubed. So this is 2y cubed, or 1 minus 5y, I think. Yes. And note, I still have my non-permissible values. Y cannot equal 0. Or 1/5. So I have to make note of that there. Okay? Now, that's honestly most of the lesson. But of course, we're going to do some more examples. Okay, moving on. State the restrictions and simplify. So what are my restrictions here? Well, note I've got two fractions with two denominators that could be. So 15x equals 0. So 15 x cannot equal 0. So that's one restriction. So I should call that's one restriction. The other restriction, my other denominator is x minus 6 can't equal 0. So x minus 6 cannot equal 0. Add 6 to both sides. X cannot equal 6. So I have two restrictions here. Now, can I start multiplying this out and canceling stuff out? Yes, I can. So I'll leave that. This is 2x times x minus 6, 15x. I'm rewriting it because it's a little bit messy there. I'm going to put the x minus 6 denominator here in brackets. Now, once you do that, you see, oh, I have x minus 6 and x minus 6 numerator and denominator. They cancel. What else? Oh, I have an x right here and an x right here I can cancel. Anything else? I'm not sure. This is getting a little messy. I'm going to rewrite this. 2 times 5x over 15. Yes, everything else is canceled. Now, once you do that, you go, oh, I've got 5 in my numerator and 15 in my denominator. I can divide top and bottom by 5. 1, that becomes 3. This equals 2x over 3. All right. And please don't forget your non-permissible values. We found them over here. X cannot equal 0. And x cannot equal 6. So this is great as long as x doesn't equal 0 or 6. As I said, another math logic puzzle. Sudoku is more fun, but still. So find your non-permissible values and cancel stuff out. Simplify. That's it. So, one more. Okay, oh, this is a little bit nasty, but it's not so bad. Notice the first denominator, 3x squared plus 6x. Well, we did one of those denominators back here where you're adding stuff. 3y minus 15y squared. Factors, simplify by factoring out as much as you can. 3 and 6, I can factor out 3. Oh, x squared and x, I can factor out an x in each term. So that's 3x times what's left? 3x squared, that would be x. That's 1x. And 3x is 2. So right off the bat, notice I have two things I'm multiplying by. So 3x cannot equal 0, and x plus 2 cannot equal 0. So I'm going to pause the recording, and I want you guys to figure out what those non-permissible values are. Alright? Then we'll come back. Okay, I got x can't equal 0 and x can't equal -2. Now, someone's going to point out, what makes something in the denominator of 5? Yeah. Can you make 5 not equal to 0? Not in this course. And if you want to get real picky, it's 2x over 1. Can't make 1 not equal 0. Right, so you don't worry about those. Only when it's got a variable in it. An x, a y, a b, an a, whatever. Now, the next part is simplifying this mess. So, 12x cubed. Now notice I simplified my denominator here. That's 3x or x plus 2. Now, 4x cubed plus 8x squared. I have to simplify that. Oh yeah, 4 and 8, I can factor out 4, and I can factor out an x squared. And that leaves me x plus 2, I think. Yes. 5. And don't forget the times 2x. Now, what can I cancel out here? Because life is too short. Oh, no! I have an x plus 2, and an x plus 2. I have one x and an x, 3 and 12 is 1 bit. So I'm down to, this is getting messy, so I'm going to rewrite it. 4x cubed times 4x squared times 2, 5. Which simplifies. 4 4s are 16. I think that's 32 x 5, 5. X, don't forget your now permissible values. X cannot equal 0. And x cannot equal -2. So that's what I expect you to be able to do. Now, annoying? Yeah. Doable? Yes. Okay. So far, so good? Okay. Now, just double check that. All right. Now, how do you guys feel about this? Another example? Oh, sorry. Video's getting too long. I'm going to pause this. We're going to go on to division. My apologies. So, review this. If you got it, go on to the sneaky divisions.